Hello, my name is Ken Nakagaki. I'm currently an assistant professor at the University of Chicago. In this talk, I'm presenting Appearables, which is one of my last research projects at the MIT Media Lab, where I completed PhD last summer. I'm presenting this work on behalf of my amazing collaborators at the MIT Media Lab and the University of Southern California. So the starting question of this research is quite simple. How can we make physical objects appear and disappear? While making graphical objects appear and disappear on screens or VR headset became super easy, doing that for physical objects or tangible user interface system is really difficult. While prior research has preliminarily explored such an expression, either using motorized mechanisms or inflatables, they have limited expression with a fixed mechanism and configurations. In our work, we were greatly inspired by the prior work in theatrical performance or human-robot interaction research to design appearing and disappearing expression by utilizing surrounding stages. So in our research, we introduced a novel approach to design actuated or robotic tangible user interfaces in conjunction with stages. Stages are surrounding environment of the robotic hardware, and with stage, we open up a novel opportunity to make physical objects and user interface elements in physical environment dynamically appear and disappear. This allows a number of interaction design, physical expression, and applications that greatly enrich our physical environment. This paper is extended research based on our previous paper, Hermits, where we have introduced the concept and approach of mechanical shells using tabletop robotic hardware, Toyo. While our Appearables implementation is based on the same technical approach or platform, this paper explores the remaining component of the system, which is the interaction stage, to augment the interaction and expression of the actuated TUI system. So this is an example overall design of Appearables. By extending the stage of Hermits to have front stage and back stage, now the actuated TUIs can transit between the front and back stages so that they appear and disappear from user's perspective. As shown in this diagram, with the duality of front and back stages, it opens up a whole new interaction design opportunity for the physical hardware system. Let's break this down into several components. Firstly, the transition portals are the essential element in the design of Appearables. They are basically pathways for the robotic hardware to transit between front and back stages. We have prototyped a variety of portal designs such as this curtain, or actuated doors, or even a lift for the robots to appear from the floor. In our paper, we categorize the portals into 4 quadrants design space, where each of them can be utilized depending on the use cases and applications. These transition portals facilitate the expression of appear and disappear. We also have this design space for the rich expressions or illusions our approach can convey. For example, by combining the basic effect of appear and disappear with graphics like display or projector, the system can create expressions of transition between pixel and physical. Or by combining multiple robots to make one robot disappear from one place and appear another robots at another place simultaneously, it can create illusion of teleportation. These are later demonstrated in the application sections. So that is the transition portals that facilitate appear and disappear effect. Now the backstage allows the system to intentionally hide certain processes which may better be not seen or intervened by users for interaction design purposes. Such process may include reconfiguring and assembling with other modules as preliminarily demonstrated in Hermits. Or even digital fabrication machines themselves could be embedded in the backstage to fabricate different shapes. With this, robot can pick up from the 3D printer and bring to the front stage for users. So that is the core idea of these Appearables, composed with front stage and the backstage connected with transition portals. For the implementation, we have prototyped the stage design and control pipeline. In the plan and design stage, we have developed a GUI tool to design and iterate stage models where users can define different properties for the stage. The design is visible in the 3D model for the users to view and simulate the stage. Then the data is exported to be used for both fabrication and robot control on the stage. So based on this stage data, a user can fabricate the stage using different fabrication techniques. For controlling and navigating multiple robots on the stage, we have employed MAPF, multi-agent path finding, to automatically generate paths from designated origin points to target points. This is a technique and research well developed in action planning for warehouse robots, and the detail can be found in our paper. Based on our prototype, we demonstrated potential applications. First, Disappearables can be used to enhance the interaction with data, where users can switch between GUI and TUI by allowing the robot's hardware to snap to graphical system on demand. Secondly, Disappearables give novel opportunity for everyday affordance design. For example, it can make your phone disappear rather than turning off the notification. As our phone have become the most distracting thing in the world, such a radical new take on affordance design may be effective. Accordingly, different types of user interface elements can appear and disappear to design different types of physical affordances. Next application is for remote communication or gaming. Here you can see two users enjoying remote physical hockey where a puck would disappear from one side and appear on the other side to represent the continuity of the remote space. Lastly, Disappearables can also be utilized for playful and expressive application in physical gaming and storytelling as well. So in our paper, we introduced the concept and method of Disappearables by designing surrounding stage for actuated tangible user interfaces. We believe this research is literally a stage for many other research to explore or perform future research opportunities. Such research directions include stage control and design, user evaluation, and designing stage for other actuated user interfaces. Lastly, I would like to thank my co-authors and collaborators, of course, including my advisor, Professor Hiroshi Ishii. And please feel free to reach out to me for any questions or inquiries. Thank you.